Hi everyone, my name is Nyarin and today I'll be presenting my recommendation report. My topic is how the United States can capitalize on its massive wind energy potential. So for the introduction, the United States actually has the greatest potential of transitioning the world into the renewable energy sector. And why wind energy, you may ask? Wind energy actually has the greatest potential for growth in the United States. Looking at the key areas of focus, first, we'll be looking into ways to improve the current wind technology we have. We'll be looking into the new wind technology we have. And finally, we'll be looking into ways to identify locations with high wind energy resources. So for the background information, we'll be looking at the horizontal wind axis turbine, the most commonly used turbine. You can see it in the image in the background. It costs about 1.3 to 2.2 million USD. And the biggest disadvantage with this is its high operation and maintenance costs. Looking at some historic trends from 2010 to 2018, our energy output from wind energy has increased by threefold, which is pretty impressive. And currently, our installed wind energy capacity is enough to power 33.7 million American homes, and that's just the tip of the iceberg. So looking at the problem statement, our years of reliance on fossil fuels has led to increased carbon dioxide emissions. And consequently, it has led to global warming. So a solution to this is wind energy, because wind energy is a clean source of energy. Looking at the first part of the analysis, we'll be looking into the new advancements in the wind energy industry. We have the spider float offshore platform system. So this is basically a floating platform which supports wind turbines on the ocean. So each float here, shown in this diagram here, is tethered to the ocean floor using high-strength cables. And traditionally, how we supported these turbines in the ocean is we had steel structures which support the turbine, which span the entire ocean floor. And that is a lot of steel, which costs a lot of money to maintain. These cables are a much cheaper alternative. So the disadvantage with this floating system is because it's floating, it's susceptible to the movements of the wave, and therefore it can damage the components and interfere with the wind energy transmission. Moving on to the vertical wind axis turbine is also recent technology. It's very similar to the horizontal wind axis turbine, but it has some differences. So the biggest advantage and difference with this is it's much smaller and shorter, which means it has lower installation, maintenance costs, transportation costs, and they can be placed closer to one another. The only disadvantage of this is because it's smaller, it has a lower efficiency. Its shorter height means it has less wind capture. The lower your altitude, the lesser your wind speed. So moving on to the second part of the analysis, we'll be looking to ways to improve the current wind energy technology we have. So this is a robotic blade inspection system, which we deploy on the wind turbine, and it uses ultrasonic technology to detect subsurface damage. Now, this is where this technology stands apart. So subsurface damage is damage that cannot be seen by the human eye. So traditionally, we use human-piloted drones to visually inspect these blades, and they cannot detect this subsurface damage. So by detecting the subsurface damage at an early stage, it can avoid potential costs because it can avoid these damages from growing into a critical size. So yes, it saves potential costs. And it can also perform these inspections at a low cost in general compared to the traditional human-piloted drones. The only disadvantage is because it's new technology, it cannot be mass-produced yet. So for the third part of the analysis, we'll be looking into the ways to find high wind resource areas. We have this LiDAR technology, which is basically a boat we place in the ocean. It will collect wind data or in general offshore wind data, which helps developers make feasible decisions on whether to establish an offshore wind farm or not. They need this information to make those decisions. The greatest advantage of this is it can capture measurements at turbine level height, which is 200 meters, which is the most important data point when it comes to offshore wind data characterization. The only disadvantage is it's very expensive. This project alone costs 1.3 million USD. So as a conclusion, we have a lot of potential in the wind energy industry. And for my recommendations, first, I would definitely recommend the vertical axis wind turbines, the smaller ones, for powering residential and school areas. It's a great start, it's cheaper and it's smaller. Second, I definitely recommend the spider float platform, and we should give more emphasis to the offshore wind energy, because offshore wind energy actually has higher wind currents throughout the year compared to onshore wind energy. I wouldn't recommend the robotic aeroblade system because it's still new and cannot be mass produced, and the LiDAR boat system is way too expensive to be feasible. Here are some references. So, thank you for listening. Have a good day.